Hi guys, so this video is just gonna be a continuation of my previous video. And so in the previous video I told you guys how to find the length of a space curve, and I did a problem on that, and the problem was with the variable a and b. So you guys didn't have a problem with the interval, like a numerical interval. So this time I'm doing a problem with the numerical interval. So this is like a part 2 of that video. So if you haven't watched that video, I'm gonna upload the link in the description below so you can watch it. Okay, so now let's continue with this video. So as I told you in the previous video, the length of a space curve is simply, how do we do that? So formula is simply taking the derivative of the vector function and then taking the magnitude of it and then integrating from a to b, like the interval given. So this is simply the formula to find the length of a space curve. Okay, so here we are given a vector function, so we'll have to first do what? So our first step is to take the derivative of the vector function. So taking the derivative of the vector function, so first the vector function is given as f of t plus g of t. Not like that, wait. So rt is given as f of t I hat plus g of t k hat plus h of t. My god, I'm so confused. And k hat. Okay, and r prime of t, taking the derivative of it, it's gonna be f prime of t I hat plus g prime of t j hat, and then h prime of t k hat. So here this is f, this is g, and this is h. Okay, so if you do take the derivative of this all together, it's gonna look really messy and it's gonna be really hard for you. So we're gonna break this into components and then find the derivative of it. Okay, so now let's breaking it into components. Give us, so r of t is given as so r of t, the first thing you see is f of t. So we're writing f of t, so it's e to the t cos 2t, and then find f prime of t. What's f prime of t? So here you see it's a function of two variables. It's made up of two functions. Okay, here you see e of t and cos 2t. So that means we'll have to take the derivative of it, we'll have to use the product rule. And you guys remember the formula to find the product rule? So it is like product rule, it is f prime times g plus g prime times f, and the first function, assume it f, and the second one g. Now let's taking the derivative of it. Okay, so here, write it here, f prime, oh, I need to change color, insert white. Okay, so f prime of t, it's gonna be, so the first function f prime, derivative of e to the t is simply e to the t, it's the same thing, and then putting g, like not taking derivative, simply g. Okay, and then g prime, derivative of cos t, so you guys should know it's negative sine 2t. And then here it's a chain rule, we have to multiply by the inside function as well. So what's the derivative of 2t? Like it's sine 2t, right? And then multiplying it by the derivative of the inside function. So inside function here is 2t, the derivative of 2t is simply 2. Okay, so now derivative times 2, and then here f, so multiplying with f, it's et. Okay, et. Now just gonna write this clearly because it looks a little messy right now. So here, cos 2t e to the t and negative 2 et sine 2t. So here I just wrote it in a better way, it's the same thing. So now this is equal to, this whole thing is my f of t. Okay, now let's finding g prime of t. So gt is given as, let's scroll, so what's the gt? Wait, so gt is given an et sine 2t. Okay, so let's go back. So it's et sine 2t. Now taking the derivative of this, g prime of t, which is equals to, again, product rule. So f prime, this is f, this is g. Okay, now it is f prime times g plus g prime times f. This is the formula. So f e to the t, g prime, f prime, so the derivative of e to t again, and then g, so it's sine 2t plus g prime, so derivative of sine 2t, derivative of sine 2t is cos 2t, and then multiplying by the inner function, which is 2t, so derivative of 2t is 2, and then multiplying it with the f. Okay, so f is et. Now writing it in a better way so you can see it clearly, then 2et cos 2t. So here, this is g prime of t. Okay, now we'll have to find h prime of t. So h of t was simply, I think it's e to the t, but let me verify. Okay, yeah, it's e to the t. So it's e to the t, and then taking the derivative of each e to the t, it's simply e to the t. Okay, now I'm gonna write everything all together. So writing r prime of t all together with f prime of t, I hat plus g prime of t, j hat plus k prime of, h prime of t k hat. So let's do this. So here, this is f prime of t. Okay, so I'm gonna copy it from here. So okay, let's copy this, copy, and then I'm gonna paste it in here. So this is my f prime of t, and here it's missing an e here, so I'm just gonna write an e here. Okay, and g prime of t, I can see it's in here. Okay, so this whole thing is I hat, and then plus this g prime of t, so e to the t sine 2t plus 2 e to the t cos 2t. So this whole thing is j hat, and then h prime of t is simply e to the t k hat. Okay, so yeah, it's in here. Let me show you h prime of t here, e to the t. Okay, let's scroll down. Okay, so here we have r prime of t, and what's our next step? So the formula is r prime of t and then magnitude, and then a to b integral. So what's the next step? Yep, the magnitude. Okay, and you guys remember taking the magnitude? Okay, so to take the magnitude, what do? We square each component and then square root the whole thing. Okay, so let's square each component. I squared, g squared, and k squared, and then taking the square root of the whole thing. So I, j, k, you don't have to write it because we're squaring it, and then even the negative, you don't have to write it because we're squaring it. So now what are we left with if we square it? So et squared, and then cos squared of 2t, and then plus 4 et squared sine squared of 2t plus et squared sine of 2t squared plus 4 et squared plus, no, not plus, so sorry, so where I was I lost. Okay, so 4, so here I am, 4 et squared cos squared of 2t plus et squared. Okay, so this is what gives us after squaring each term. And yeah, not forgetting the square root because I always forget it. Okay, now, so you're just adding these two. So like for example, when you add numbers, okay, 2 plus 3 plus 6, so this is the same as 6 plus 4 plus 2, right? So the order doesn't matter, so you can just swap them. So that's what I'm gonna do. So I'm gonna put the like terms together. So here et squared, so here I have et squared as well, so I'm gonna put them together, and you'll see in a minute why I am doing this. It's gonna be useful for you, okay? So just bear with me. And then cos squared of 2t is now cancel. Okay, now you see they have the same let's say coefficient. Okay, so I'm gonna write them together. So et squared sine 2t plus, and then this one et squared cos sorry, it was square, cos squared of 2t, and then when everything is cancelled out, only this one is left, so et squared. Okay, and yeah, not forgetting the square root again. Okay, now do you know a trig identity which can make it easier for us to solve this? So yeah, if you don't remember, let me give you. So it's sine squared plus cos squared is equals to 1. So this is what you need to know to simplify this expression. So here you see, if we factor out e to the t, we're just left with sine squared of 2t plus cos squared of 2t. Okay, sorry, there should be an x here. Okay, so here let's factor this out. So we're left with sine squared of 2t plus cos squared of 2t, because you see e to the t squared is in both expressions, so we just simply factor this out and we're left with sine squared and cos squared, and 2t is just like x, so we can replace this by this trig identity, which is equals to 1. Okay, now let's moving on. So here we are here. So here you see these two expressions have the same coefficient, e to the t squared, so let's factor this as well, the t squared, and then we're left with sine squared of 2t plus cos squared of 2t. So here again we can replace it by 1 using this trig identity, okay? And at the end we're left with this e to the t squared. Okay, now, and yeah, the square root is important. Okay, now e to the t squared, this is replaced by 1, so we don't need to write it, and then plus e to the t squared plus e to the t squared. Okay, now let's adding all of them. So here there's a coefficient of 1, so this is gonna be 2, and then 4, so this is 6. This is 6 e to the t square. Oh yeah, that wasn't square in here. Okay, now this is same as if we multiply them out. So okay, so here square root of 6, it's a decimal number, so I'm just gonna leave it. And here if we do this square and square root, this cancels out, so we're left with square root of 6 and then e to the t. Okay, so this is our expression by after doing the magnitude, like after doing r prime of t and then magnituding. But we're still not done. There's one more step left. Yeah, integration. So this expression is this. Okay, so now we're gonna replace it by 6 e to the t, and e to the t, 6 e to the t, and then integrated from, so what was the interval given? So the interval given is 0 to 3 pi. Okay, 0 to 3 pi, so replacing it by 0 to 3 pi, so 0 to 3 pi, the lower bound and then the upper bound. Okay, and now since square root of 6 is a constant, so we can move it outside the integral, so 0 to 3 pi, and then e to the 60. If you don't want to move it outside the integral, it's up to you, but it's always easier to do it this way. And now integrating e to the t. So you remember how to do the integral of e to the t? So you know, in what are integrals? They are just like undoing the derivatives. Okay, so if we want to find the derivative of e to the t, what is it? So it's e to the t, right? It's the same thing. So here in this direction we're doing the derivative. Okay, but if we want to find the integral, so what is it? It's like undoing the derivative. Okay, so this is the derivative. So if you want to go to the original function, so like we're undoing the derivative, so going in this direction, so undoing the derivative gives us e to the t as well. So it's the same thing, it doesn't matter. So the integral of e to the t is e to the t as well. And then integrating, and yeah, not forgetting the square root of 6, and then integrating from 3 pi to 0. Okay, so here we have square root of 6 times e to the 3 pi minus 0, and then, oh, not 0, I mean e to the, because it's e to the t. Okay, so e to the 0, because these numbers will be replaced by t. Okay, so here it has to be like e to the t minus e to the t. So here it's the first one is replaced by the 3 pi and the second one by 0. So, and what's e to the 0? It's 1, right? So it's 1. And now the final answer is square root of 6 and e to the 3. Okay, e to the 3 pi minus 1. So this is the final answer. I hope you find this video helpful, and thanks for watching. Bye.